So let's start. And so why we need Oracle? You know that the first successful blockchain application was Bitcoin. And with Bitcoin, you could exchange, store, and mint Bitcoin in a trustless, secure, and decentralized way. As you've seen, I used Bitcoin with capital B and Bitcoin with small b in this sentence, because before the word blockchain was used, we only had Bitcoin. So to distinguish between the framework, the platform, and the cryptocurrency, we used Bitcoin with capital B to refer to the blockchain, and Bitcoin with small b to refer to the cryptocurrency. So with Bitcoin blockchain, you could exchange, store, and mint Bitcoin cryptocurrencies in a trustless, secure, and decentralized way. And Bitcoin blockchain was designed to be a peer-to-peer electronic cash system. And despite the great hype about Bitcoin, it was soon clear that apart from a few scripts like time locks and multi-signature wallets, for example, it was not really suitable for much more about that. So with the aim of offering more functionalities, Vitaly Buterin proposed a new blockchain ecosystem named Ethereum, which was the world computer. And with Ethereum, you could execute any sort of program that was called smart contract, enabling an infinite range of opportunity for application to be built on a blockchain. However, there were some limitations, but one limitation in particular. Well, you know that to ensure the security of the ecosystem of blockchain are isolated from the real world and other blockchain, of course. And so they are totally unaware of event happening outside the ecosystem. So they have no mean also to fetch extrinsic data. So even if with Ethereum, you could program any sort of, of smart contract, without the access to real world data, you cannot do much more above the exchange of cryptocurrencies. So the range of possibility was still extremely limited. Just to make an example, with Ethereum, you can program a smart contract to make a swap between two cryptocurrencies. But to do a swap between two cryptocurrencies, what you need to run the smart contract is the exchange rate between the two cryptocurrencies. But this data is not available on a blockchain, and the blockchain has not a mean to fetch extrinsic data, because this data come from the market, okay? So it's not available on the blockchain. So basically, to overcome this limitation of smart contract, a new actor is introduced within the blockchain ecosystem, and its role is to fetch data from the external world and feed the smart contract. This entity takes the name of Oracle. Oracle, the data fetched with Oracle include lottery winner, price and exchange rate, so for DeFi application, dynamic data like time measurement, weather condition, for example, for insurance contract, or political event, sporting event like for gambling application, geolocation traceability information. As you know, blockchain is also used for traceability thanks to Oracle data, and also for event in other blockchain, because oracles are also used for interoperability. So how do Oracle work? Basically, well, Oracle are of different kind, but mainly they have three components, let's say. The first component is the data source. So where the Oracle takes its data, that can be an API and a hardware connected to an API, or also a human connected to an API. Then there is a communication channel. And this communication channel basically has the role of taking the data from the data source and securely transmitting the data to the smart contract. This communication channel is also referred to as node or trusted execution environment. And then there is the blockchain code, the smart contract, that basically has the information about how digest the external data. So you can digest the data as it is, or you can make a media, an aggregation, and then oracles are also are of different type, but we can divide them in two main categories. We have vouching oracles. For example, vouching oracles rely on a trusted third party aware of a certain data type and mainly ensure that the data is securely transmitted to the blockchain. To make an example, if you have an insurance smart contract for a flight delay, the smart contract may ask the flight company if the flight has delayed or not. If the flight company says that the flight has delayed, so the smart contract can be executed and issue the refund. Or we have voting-based oracles, and a voting-based oracle relies on multiple data source or node, and it reach an agreement on the data to upload on the chain thanks to a voting mechanism. For example, if you have a gambling platform and you bet on a match, on a football match, the smart contract can ask maybe 10 data source, 10 nodes, which team who won the match. And if the majority of nodes says that team A won, so the people that bet on team A will be, of course, will earn the reward.